Hi, I'm Jonas. I'm a PhD student at Dortmund University, and today I want to show a bit of my research about how we could perhaps leverage conflict tolerance to make parallel working safer, so that we can work in parallel without fear in local first apps. So live collaboration is like the default mode of collaboration in many local first apps, which is awesome. But sometimes you really want to work alone to just avoid interruptions for a few hours, work independently. Perhaps you want to work offline for a longer period of time, or perhaps you just want to keep your ideas to yourself for a bit so that you can flesh it out and present it to others later. But if you disconnect from your peers and work alone, it means that concurrent edits will pile up your edits, the edits of others, and at some point, if you're using CRDTs, which is very popular at the moment, these CRDTs will eventually merge them and they will use automatic conflict resolution, but this can silently discard any edit, right? And you have no real insight into what happens to my contribution, what happens to the contribution of others, and how what is actually preserved and what is discarded in this automatic conflict resolution. So what you really want in this kind of situation, where you want to work independently, is like a proper version control system, where you have branches which were designed for exactly this purpose. But the big problem here is that conflict resolution is still a huge pain, right? If you merge, you have to resolve all these conflicts by yourself, manually. If you think of how Git is working, for example, there's always one unlucky person who's stuck with a conflict, right? And this person has to resolve the conflict immediately, because Git just stops working at this point. They are alone, cannot share this with anybody else, and they are probably also missing important context of what the other participants were doing, what their intentions were. So the results are predictable, right? It's, first of all, you're interrupted by this merge conflict. You cannot keep on working. And then if you try to resolve these conflicts, you're probably making some premature decisions. You're easily dismiss the work of others. And this can introduce many errors that should have been avoidable in the first place. Right? So, and I believe that these problems are a big reason why branching and merging is not commonplace in local first app. Right? So it's very rare actually. And I would like to change this. And my idea to support better merging would be this idea of conflict tolerance. And I would propose to make conflicts a first-class object in the document, so that conflicts are not the exception, not something abnormal, just a regular part of the data structure. And if you arrive at this point, you can just defer the conflict resolution and keep on working, resolve the conflict later. You can share the conflict with others over the collaboration system, and then you can also start to resolve conflicts collaboratively and properly discuss what everybody's intention was, what led to this conflict. So existing research has already shown some benefits of this approach, that it can actually preserve all the different contributions, and it can uncover disagreements within a team. And the hope is that you can also make more deliberate and well-informed resolution decisions and avoid many of these errors that you would otherwise introduce. So in my research, I've implemented a CRDT that integrates syntax, history, and conflicts, which I've called lazy merging. And in general, I hope that conflict tolerance as a concept could perhaps be one of the missing pieces for this vision of universal version control, where we try to bring more advanced version control features into local first apps and provide more opportunities for more advanced collaboration scenarios. Okay. I now want to show you two examples of where I've implemented this kind of conflict tolerance. The first example is SyncoCloud, which is a language workbench that we are developing at our chair at the university. Actually, it now follows a local first architecture, but the name is still the same. This is about domain-specific languages and graphical models, visual programming, and we're using Git as a version control system in our language workbench. Right. So what I did there was develop a custom merge driver for Git, which is nice in Git. You can just plug in a different merge algorithm if you like to, and with this custom merge driver I could implement a structured merge and a conflict-tolerant merge, and I introduced this kind of conflict representation in our core data model of the model files. Right? Usually a target ID of an edge, for example, would just point to one Rio ID, but if we get conflicts, I insert these kind of conflict markers that indicate choice, and in the application, in the UI, I am considering these conflict markers from the data model, and I can render the different options of a conflict. Right? So you can see here that this edge either points to this or this image. There are other conflict types as well, like here would be an edit-delete conflict on this edge. And yeah, so this would be the first example.
Will you share the presentation?
Yeah, definitely. Yeah. So for the second example, I want to start with a demo first. Let's hope this works. So I built just a small graphics pipeline. Right, you can pull in a few images here and a few transforms and see what happens. It's implemented on top of auto merge, so it's collaborative. Let's see. Right. So this is the idea. And now if one of the participants goes offline, then all the edits become concurrent, right? So if participant 1, for example, would connect this funny pointy head, and the second participant would rather connect the checkerboard, we'll get a conflict, right? But because I'm handling conflict as a first-class object in the data model, I can just keep on working. Right? I can still change the pipeline, move things around. I can see exactly where the conflict is coming from, what are the different options that I have here, and more importantly, I can keep on rendering in the pipeline. I just render all the different combinations that are possible from the conflicts that are existing in the pipeline. Right? And I can go even one step further and render this in Word as well. And before I even decide anything, I can already see the impact that my decisions would have. So I can look in the last panel and perhaps say, okay, I'd rather like the checkerboard. The other participant can see exactly the same, right? And any of the participants can resolve this conflict now. So let's take the second participant to resolve it, and then it's all fine. So this is like the fundamental idea. I want to quickly show that you can also have more complex conflicts. Let's do the same scenario one more time. Checkerboard. Let's trigger another conflict by connecting here, and the second participant will just do the invert of the gradient. If we connect again, you can see this nested conflict. We can actually see all the different combinations here. In the invert, we have either the image is coming from the blend or from the gradient, and we can incrementally resolve this. So, for example, we could first select the blend and then again select this conflict, and we would be fine here. So, yes, this is a bit of a demonstration of how we can continue computing even if conflicts exist within our model. So, just to
what happens if you're offline and you like have a conflict in the selections?
If you're offline and you have a conflict in the selection,
Like one person selects left, and the right person
it will just
selects
be a regular conflict again.
It makes sense.
It's fine. Good question. Okay, so this was built on auto merge. And auto merge already includes a simple conflict representation for these kind of conflicts. They are showed in the demo, so you can just call automatically conflicts and you will get the conflicts object, and this is what you can then incorporate into your data model and work with. Yeah, and then as you saw, from this conflict representation we can come to this conflict visualization and collaborative resolution. So, okay, what are the challenges of this approach? Right? And here's a small tutorial on how to implement a conflict-tolerant local first step. The first step is to implement a conflict-tolerant CRDT, and then you just adapt the rest of the application. So, yeah, I believe conflict-tolerant CRDTs are not that difficult, right? You can just use a multi-value register, for example. Perhaps you even implement your own custom merging semantics, but that's probably the easy part and the part that is easiest to reuse across projects. Right? The hard part of this approach is threading the conflicts throughout your whole application and considering the conflicts at different points in your implementation. Right? Because this kind of conflict tolerance is just a kind of pervasive cross-cutting concern, similar to error handling, which is another thing that you have to consider in different parts of the application. Conflicts flow through your whole applications as well if you follow this approach. Yeah?
Would you go as far as to say that a fully deterministic CRDT may not be optimal? It's better to have conflict because there's value in the resolution.
So yeah, I would support representing all the conflicts as truthful as possible or to preserve as much information as possible. But of course, it is still deterministic, right? These are still CRDTs with all the formal guarantees of eventual convergence and eventual consistency, right? So this is about keeping the concept of CRDTs, but not enforcing this conflict freeness. Right? So the convergence of CRDTs should that does remain and is untouched by this. So the question is, how could we make this easy? Because perhaps this is cool, perhaps we would like to reap these benefits, but it's hard to implement, and perhaps we can develop conflict-tolerant UI frameworks that include some conflict visualizations in the widgets that we can reuse. Perhaps we can have conflict-tolerant databases or query languages, and perhaps you can even think about conflict-tolerant APIs or programming languages to express our business logic with conflicts in mind, right? And I'm thinking, I just recently saw this MSheets project from Switch, which pioneers this kind of multi-valued computation in a spreadsheet. And this is the kind of technology that would be a perfect fit for some kind of conflict-tolerant calculation, because conflicts usually mean the same, right? Some properties are multi-valued, for example, and this is a cool application of this idea. So, yeah, this is my presentation. Thank you.
First a question, and then maybe a comment. Have you thought about using different concepts to talk about these sorts of collisions and conflict? Because I found in my own research that whenever you say conflict, people get really alarmist, and they're very nervous, and it's a conflict. But what I just saw, and this is the comment, what you develop essentially is not just a conflict resolution system, it's actually also a parallel branch visualization thing. So another really good use case for this is, I'm a designer, I want to explore three ideas at the same time next to each other. Is it a conflict? I don't think it's a conflict. It's a decision that hasn't been made yet, right? So is there better words, ways to describe it that we can come up with to talk about parallelizing systems?
So I've been calling it variant potential at some point, but I'm coming back to the term of conflict because there's this tension between merging and varianting, and how these two fit together and don't fit together. Right? I think we can talk a bit longer about this later. It's an interesting topic. For now, I'd rather stick with this kind of notion of conflicts, because in my mind, this is still something that you want to eventually resolve. If you have this kind of different variants, I still believe you would need to add another concept or conceptual design to this, and just this kind of conflict representation would not be enough to give you a good experience in this world where you want to have different variants and configurability.
How is this different to multi-value register? Is it that you keep more semantic information about the conflicts, like where they came from?
Yeah, so in the demo, that was just the multi-value register, right? As I said, the CIDT part isn't that hard in this concept. It's more about thinking what the user experience should be and what you can do with it if you accept it. Like, how do you have to adapt the computation of a graphics pipeline if there are conflicts everywhere? And you get this kind of exponential number of different possible renderings. Right? So yeah, good point is yeah.
Our application is we store the changes from our merge between one revision and the next one. In a memory way, and then you can do graph analysis on top of this structure to see which user changed which property and what was there before. So you have the deck view, like the graph. You can click and see what was the materialized document at that point in time and what was the previous one. So that's more, of course, the developer stuff. Not something that's pretty fancy for the UI, but as a developer you want to know what's happening here. Why does it cause a conflict or why does it not cause a conflict? Because how much is good in the merging stuff where you might have wanted a conflict and that's why we're doing some conflict search in that graph where did something get swallowed, for example.
Yeah, auto merge is definitely awesome for this.
That's
Sounds like you.
what auto merge is doing here, which is not, I think it's already good, but
Yeah, I believe so too. Yeah, so it sounds like you implemented some kind of more advanced analysis of the conflicts. And you can uncover a lot of information there. Like, it's often also interesting to know how different conflicts relate to each other. Right? Which options happen on the same branch, something like this. So yeah, there's definitely value in this. Yes?
So if I understand correctly, you have some things that you decide to visualize conflicts for, but other things where you don't, right? Because for example, if two people are concurrently moving a node, then you'll just reconcile this change without showing a conflict, is that correct?
Yeah.
Have you found like a heuristic or something where you, for like developers to understand when they are supposed to show a conflict or not?
I mean, it's mostly a judgment call, I think, and considering if a change has meaningful semantic impact, right? So, for example, moving a node around, the worst thing that happens is that everything's a bit unorganized, but the pipeline stays the same semantically, right? So this is probably something where you don't need to think about some complicated conflict visualization. When it comes to the semantics, or if it influences the final output, it's probably a good idea to visualize this and represent this.
Am I right that I'm not super familiar with how AutoMerge models conflicts, but from AutoMerge's perspective, when you are visualizing a conflict, from AutoMerge's perspective, is the document in a conflicted state anymore? Or does the document resolve that you kind of introduced your own kind of
It's kind of both with AutoMerge. So AutoMerge handles this case by picking one option and giving you a consistent document, but you can get the underlying conflict on demand.
Got it. Okay. So from AutoMerge's perspective, the document is fine. From the user's perspective, the application level, there's a decision that needs to be made.
Yeah, right. But AutoMerge also presents me with the conflict. So this is also coming directly from AutoMerge. It's not something that I have to track myself.
Yeah.
Right.
That's cool.
Yeah.
Have you done this on top of Jiu-Jitsu by chance? JJ?
No, unfortunately not. I know they have also have an internal conflict-tolerant representation, because rebasing would be a huge pain in some cases otherwise, but I don't have too much experience with it.
In JJ, for example, from my understanding, they like conflict resolution is not a blocking operation like it is in Git.
Yeah, definitely. Yeah.
And do you have like code for this, or is it just slides? Like, is there actual code that you can
Yeah. So you can look at the code on this website. You can check out the demo. Yeah, sure. I think I published most of this stuff somewhere. Yeah.
So that looked really nice and useful. Just imagine if you have piling up conflicts, does that not explode like living in millions of possible worlds?
Yeah, definitely. Yeah. So I think as a user of this, you have to find a kind of balance between waiting longer because you need to discuss or uncover more information, and there's also a point where I think you have to make a decision to not aggregate too many conflicts, and then it gets unwieldy in any case. Right? So it's definitely a concern.
So maybe you could add sort of limit time of life or something to the conflicts.
Yeah, like a warning, like
which just goes off.
Yeah, definitely. Yeah.
Maybe related to that question, related to something else. Have you considered like showing only your own version and saying there is a conflict, there are other things that this could be like, because you are in the context of like.
I think there are 2 more sessions.
Oh yeah.
We maybe
Sure, of course, yeah.
take this conversation to the hallway so that we have more time for the rest of it.